of human psychology, of superorganisms, and then I looked at how we can find their counterparts in human psychology. So first I'm going to show you those 5 properties, which I have basically derived from my own reading of superorganisms and major transition. And then I looked at human psychology, sociology, and also anthropology to see how do we, or where do we find them. I tried to see whether we find any corresponding behaviors in humans. Okay, so here is my list of the superorganismic properties. The first one, a very basic one, is mechanisms to integrate individual units through communications. Okay. Second one, mechanisms to achieve unity of action, so united action. Low levels of heritable within group variation, and common fate is number 4, and number 5 is mechanisms to resolve conflicts of interest in the collective's favor. So I'm now going to go through each one of them and tell you what I have found in the literature on human psychology that correspond to these properties. So the first one, mechanisms to integrate individual units through communication. So I'm going to talk about 2 types of communication in humans. And the one is symbolic communication. And we know that to be very, very foundational to all of human sociality. It's an extremely versatile means of communications, and it unlocks possibilities that are not available to other species that are lacking this kind of communication. I'm also going to talk a little bit about nonverbal communication and how it can integrate with. So, first of all, symbolic communication language. Language is basically implicated in all the other superorganismic properties that I'm going to talk about next. So that means that language really, again, is foundational to human sociality. So it facilitates coordination planning, which allows united action. It enables social control, and it also it's basically a means of social control, which allows which reduces the cost of cooperation and increases its value. So symbols are interesting because they can promote group identity by also defining who is in and who is out. So basically, the questions like why are there so many languages and why do languages keep changing, which are actually kind of the same question, slightly different the phrase. One answer to that is language really allows to draw social boundaries. If you cannot speak a language, you cannot socialize with a group. And language also is a means of bringing people, creating groups out of people. So symbols can hold up extremely large groups of people, especially with the technologies of information transfer we have now. Like millions of people can consider themselves the members of a group. And we also know that newly independent nation states often first thing they do is embarking on a massive symbolic project. So they define an official language, they create paraphernalia such as a flag, an anthem, military uniforms, they change the names of towns, buildings, capital cities. So basically symbols are very, very crucial to human social group formation. So, but we do not only communicate through symbols, we also communicate through non-verbally, and the mirror neurons are activated when we both engage in an action, but also when we observe that action. And because of that, we can create corresponding internal states. We can read emotions in others. So basically, just by looking at other people, we can infer a lot about their internal states. There is another type of nonverbal communication that did not get a lot of attention, is not currently getting a lot of attention in modern psychology, and that is dancing to music, festive dancing. And the anthropological record shows that this is a very, very significant aspect of prehistoric human life. And it has also been reported by some anthropologists who have studied some tribes, and it is reported to create a very strong sense of communal bonding, and this sense of ecstasy almost. And someone has called it the biotechnology of group formation. And here is a quotation from an anthropologist who studied the Andaman Island. And as the person loses himself in the dance, as the unified community, he reaches finding himself in complete and ecstatic harmony with all the fellow members of his community, experiences a great increase in its feeling of empathy and attachment towards them. So again, another way of bonding with other humans, an altered state of consciousness through movement, which we also actually hear people, or which also seems to happen through military drill. So this is a historian, actually. The person who wrote this is a historian, and he reported words are inadequate to describe the emotion aroused by the prolonged movement in unison that drilling involved. A sense of pervasive well-being is what I recall, more specifically a strange sense of personal enlargement, a sort of swelling out, becoming bigger than life thanks to participation in collective rituals. So something in our mind seems to be open to that sense of opening to the group and becoming a part of that group, almost losing the sense of self within that group. So this was number one, mechanism to integrate the individual units through communication. I've talked about both symbolic and non-symbolic forms of communication. Communication obviously is necessary, but it is not sufficient to build an organism or a superorganism. A superorganism also needs to act as a functional unit. And do we have in human psychology any properties that allow humans to act together? So human beings can achieve things together that, again, are difficult to imagine for other species to achieve. And I identified three aspects of human psychology that enable united action. So these are shared intentionality. I will define that, and I will describe what that is. Social identity processes. Again, I will describe for you what that means. And deference to legitimate authority. So that's one way of top-down means of creating united action. Okay, so what is shared intentionality? Shared intentionality is the ability to participate with others in collaborative activities. So basically, anything as simple as two people moving this table together from here over to that corner, that is united action. And that may look very simple, but I mean, you can imagine trying to grasshoppers to do that. So it's actually very, very complex. Cognitively, it's very complex to have two people engage in the same action collaboratively, because they need to build a shared intention of what they are going to do, and then they need to adjust their behavior accordingly. So another requirement for united action is also joint attention. So we need to be first able to put our attention on the same object in the world before we can act on it together. And this is actually, again, something that seems to be specific or unique to humans, the ability to share attention with someone. And you can see that in babies or children, basically. They would point to something and they would want you to look at the thing that they are pointing to, they would not be satisfied until you also have seen that and shared that attention with them. And interestingly, this also, like this ability to share attention and to attend to what others are attending to, also is basic to language learning. So it has been shown that one of the ways language is learned in early childhood is by attending to the gaze of the people who are speaking. So, for example, if I say, where is the cup, and then I look at the cup, one can infer that what I am attending to is the cup, and that apparently is one means of language learning. Interestingly, human eyes seem to be designed to enhance the gaze signal such that we can communicate our attention, where our attention is. So a study of 81 primates found that on the human eyes, where the contrast between the skin around the sclera was had the most contrast, so that it becomes really easy to see where someone is attending to. And that again allows us to start to act on the world together. Another first step to our united action is also having a shared mental picture, a shared reality of a shared map of the reality. And human beings are really good at that. They can create, they basically enjoy sharing a reality, which is what a lot of play looks like. So, for example, when two children say, okay, you are the doctor, I'm the patient, they create a shared reality and they both can believe in that reality. And money is an example of that. Harari wrote about that in Sapiens. But we can create shared realities by sharing mental representations, even though they don't have any physical basis. So all of that allows people to act together in the world. So the second way in which human beings can act together is what is called social identity processes. And this is basically an entire field in social psychology. Social identity processes, and this is basically about identifying with a group such that people incorporate the group into their sense of self. This is not the same as liking a group or feeling similar to a group. This is really seeing oneself and the group as interchangeable in some respect. So basically seeing the self and the group as one. Right? And as a result of this overlap in the sense of self, the group relevant events also affect emotions and cognitions about oneself. So some studies showing that male basketball and soccer fans experience a testosterone surge after their team's victory and testosterone drop after the team's defeat. Again, these are a group that they're identifying with, which creates internal consequences for them. Interestingly, also political behavior is driven not by individual interests overall, but by collective interests. So people's sense of how their groups are treated is actually a better determinant of predicting or of their political behavior than their own interests and how they are being met. So for example, one study found that participation in the civil rights movement was predicted more strongly by people's feelings about the treatment of Black Americans rather than by their discontent with their own lives. Okay, so social identity processes are extremely important. I will repeat this process. It will come up again and again. And finally, third mechanism for united action in human psychology, this is a top-down mechanism, and this is deference to legitimate authority. And we know that humans conform to authority. So the Milgram studies, for example, where people were asked about this length of, they were asked like, which line is the tallest, and when they had like 5, 6, 7 people before them picked their line that was actually clearly not the tallest line, and yet usually more than half of the people picked what the people before them had picked rather than the tallest line. So people conform to authority, but we also know that the status in human groups is not based on dominance or like physical aggression. It's based on it's not taken through coercion, but it's really given based on status, and high status usually goes to people who are expected to contribute most to valued group goals. Right? So this is basically, again, one way of helping, or one way in which groups can achieve their goals by giving higher status and deferring to people who are better able to achieve those goals. Okay, leadership is also firmly tied to social identity processes. The leaders groups select often are people who can create a powerful sense of us and who is perceived as one of us and who is expected to advance the group's interests. So these were the 3 mechanisms in human psychology for united action. And the third property, low levels of heritable within group variation. And we know that in human groups, we don't have the genetic relatedness of maybe ants or bees. Migration, intermarriage are very common now, more so than ever. And genes mix across group boundaries. But in humans, phenotypical variation is also very much a result of culture, which, as we heard yesterday, it functions as a social inheritance mechanism, which promotes phenotypical similarity. And people are extremely open to social learning, called cultural learning. It arises and because people absorb language, attitudes, skills, information, norms from their group. So this power of norms was actually, like if you go to the very basic social psychology studies, you will find that like people follow norms, and the key determinant in norm compliance, interestingly, is identification with the group. Again, so in the Ash type study, psychology students conformed 58% of the time to psychology students, but only 8% of the time to ancient history students. So these are psychology students. They follow the norms of their own group. They don't follow the norms of other groups. People, interestingly, also care more about norm compliance from their own group. So people do not get as upset when an outsider follows their group's norms, but they are less tolerant toward a group member who violates group norms. This is called the black sheep effect in social psychology. Okay, so number 4, common fate. Now, common fate serves to align individual interests, because everybody basically is going, if everybody's going to get the same outcomes, I can just as well work for the group. We do know, again, in human groups, reproductive interests do not overlap much, but humans have alternative means of leveling the variation in individual fates. And one of them is egalitarianism. So basically, a sense of fairness that people have ensures that people prefer oftentimes equal or similar outcomes for others. We know, for example, that people feel guilty for surviving catastrophes such as the Hiroshima, or people feel guilty when their co-workers are laid out, but they are not. So basically, people in experimental setups are willing to pay from their own pocket to even out other people's outcomes, basically taking from the poor, taking from the rich, giving to the poor. And so envy, interestingly, is also an emotion that serves to even out outcomes, because as people try to deflect envy from others, they are more likely to share their fortunes or engaging in other acts of appeasement. And there are studies that show that this happens. So finally, reproductive leveling, like monogamy, food sharing, which are very common in human societies, also help to even out individual, the variation in individual outcomes. Another one, intergroup warfare. This is also a situation where we see the groups, entire groups' fates aligned very closely. And this we know to have been quite common feature of human prehistory. So the human groups thus have mechanisms to ensure common fate, and they did find themselves in situations that did enforce on them a common fate as well. Finally, mechanisms to resolve conflicts of interest in the collective's favor. So you may align the fate, but of course there's still a lot of conflict of interest going on. How do human groups resolve these conflicts? One of the main ways in which these conflicts are resolved in human groups are moral emotions. So moral emotions provide basically internal rewards for cooperation and internal costs for non-cooperation. And also we have some moral emotions that help us enforce costs on others who are not cooperative. So, for example, the anticipation of shame, embarrassment, guilt makes people act more in cooperative and normative ways. Distress at the suffering of others prevents us from harming others. Gratitude motivates to reciprocate benefits, which increases total levels of cooperation. And moralistic anger leads people to impose sanctions on non-cooperators. And again, in experimental studies, we find that people are willing to pay from their own pockets to punish non-cooperators. Interestingly, people also do that to punish non-cooperators who hurt other people. So we are not just concerned with costs to us, but we are concerned with third parties. We are concerned with, human beings are concerned with third parties being harmed. So another means of dealing with conflicts of interest between the group and the individual, and between individuals within the group, are using sanctions. Now, in human groups, that's actually really easy in one sense, because human beings have a very strong desire to be liked and accepted by their groups. So that makes it very cheap for other humans to exert control on individuals. So, and human groups, all human groups value cooperative norms, communicate these norms, such that most, like human groups, humans are often under pressure, social pressure, to act in cooperative ways. Gossip, by the way, is a very important mechanism for that. People's reputations are changed through gossip, and we know people like to gossip. One way of thinking about gossip is as a mechanism for, again, social control. Okay, so I have talked about the question of how human groups are like superorganisms. I will also mention when human groups are more likely to act like superorganisms. And my proposal here is that superorganismic potential in humans is prompted by external threats to the group, and it's relaxed under conditions of peace and plenty. And this we find again and again in social psychology. So a threat to the group is a major trigger for social cohesion. I'm just going to quote from a review of this literature. Group level threat combined with high group commitment is associated with perceptual, affective, and behavioral reactions aimed at the group reasserting itself in terms of either value or distinctiveness. This may lead to a high degree of self-stereotyping, expressions of strong in-group loyalty, and a readiness for collective action. So War, again, is a situation where the threat to the group is very acute, and that's also where we find extremely high levels of social cohesion. Sociologist Nisbet wrote, society attains its maximum sense of organization and community and its most exalted sense of moral purpose during the period of war. Now, this is from a philosopher, Glenn Gray, who fought in World War II, wrote, I believe that it is nothing less than the assurance of immortality that makes self-sacrifice at these moments so relatively easy. I may fall, but I do not die, for that which is real in me goes forward and lives in the comrades for whom I gave up my life. Again, this sense that I was talking earlier about of enlargement and getting enmeshed with the group, we observe in this case. So, political scientists have named these patriotic reactions to external threats the rallying around the flag reflex, and we see many examples of that. It's as increased support for leaders during times of war or international crisis. We have seen it, for example, immediately after 9/11. George Bush's approval rating plummeted from 59% at the beginning of September to 90% at the end of September 2001. And my conclusion. So, human beings display each superorganismic property and thus have the capacity to create and function in superorganismic structures. This, by the way, I do this when I teach this I don't tell you when I do it, but here is a definition. A collection of many individuals united into one body, having perpetual succession and with the capacity of acting in several respects as an individual. So, what is that a definition of? It sounds very much like a definition of a superorganism, right? So, in fact, this is, with some parts removed, a definition written by the first author on corporate law in English, and this is a definition of a corporation, actually. So, we can thus create all these different types of superorganismic structures. Group adaptation is a key mechanism that activates this potential and turns to the group a key activating condition. And now, that may be not very interesting for you, but from my perspective as a social psychologist, what is interesting about the superorganism perspective is that it unifies a unified explanation for many, many social psychological phenomena that that haven't been connected otherwise. Like the rally around the flag reflex, non-compliance, and what is the relationship between them? Like all these relationships become more clear when you take this perspective on human psychology. Thank you. Yes.
In some talks it was hinted that this kind of instruments have a huge effect in our likeness to a superorganism. You think you see anything, or this is just another thing in 100 more things? It's not that important.
Yeah, it's basically it's one of the So it goes to the second, the first one of the communication one of the it basically really multiplies the different ways in which humans interact. It connects different people. I do believe that it has the potential to, because it increases connectedness, information transfer, it can help superorganismic potential. But it can also distract from that potential, like when people do their own. So I think it creates a lot of potential, which way this potential will be. Yes.
What's your null hypothesis here? Mm-hmm. How could you reject the hypothesis that the human society is a superorganism?
So the way I would have rejected is that if I looked for those properties in human psychology and if I did not find any evidence for them, for example, if I had not found any ways of evening out the fate in human groups, if I had not found any ways for communication, any evidence for communication information based on resolving disputes, then I would have concluded, well, you don't necessarily have these problems. So, by the way, also as I mentioned at the beginning of the talk, first I'm trying to answer is not are human beings superorganisms or not. And my conclusion also is not human beings are superorganisms.
What about if you look at the community microorganisms
And
ask if they conform to your criteria of a superorganism?
So someone like you who is an expert on that topic can go through the same exercise.
Yes, and I think I would conclude that they're a superorganism.
Okay. And all right. Okay. Any other questions? Yes, please.
Yeah. We don't need it. Okay. So thank you for the talk. I think it's a very important one, and it's very important also to realize that regarding the superorganism thing, I mean, there are clearly two traditions. One comes from Spencer, actually, who used the term superorganism, and the other one is coming from biology, especially Wheeler. And Wheeler was the guy who actually linked the superorganismality idea to the appearance of terminally differentiated, unmated castes in social insects, right? That's the worry. Obviously, these two things mean completely different things, right? So it's an obvious thing to say that humans, are not superorganisms in the terms of Wheeler. Question is whether you can be more operational than Spencer used to be, because that line led to these uncritical harmony and this is the Emerson type of, so which of course was undermined. So what is very important in this presentation is that you can reach the kind of cohesion, unity, common action by things that are adaptations, but they are cultural adaptations, right? So when people are denying the importance of this, they are looking at the wrong, they somehow would like to see that at the biological level, which is obviously not there. But these things are very important, definitely, for the group level dynamics. And this is where one should look at the things, right? So I very much endorse this approach.
One more question. Anyway, well, why don't we go with here? I'm not.
Yeah, I like your general approach that you don't try to argue whether we are a superorganism, but whether somehow we behave as if we are a superorganism. But I'm really interested in the source of selection of some of these traits. And I'll give you an example. If I look at a school of fish or flock of birds, sometimes they really act very synchronously, and they fly together or swim together, and they behave like a superorganism. But in this case, sometimes people will argue that the source of selection is not necessarily a group selection level, but actually it's a selfish herd mechanism. So some of these mechanisms that produce a superorganism like behavior can be individual selection. In some cases, selection that is group trained selection. We talk about distinguishing between some of these mechanisms which reach the level of selection.
Yeah, so I am not really qualified to answer this level of selection question. So all I can say is that when we look at human groups, we see a lot of the properties that look like they may have been selected at the collective level. That in itself suggests that maybe it has happened. Also, we know that a lot of these depend on positive reinforcing, like self-reinforcing cycles, like between the individual and the group level selection, such that a trait is selected for at the collective, at the individual level, which makes the collection more likely to look for it in the next iteration, and so on. So I cannot answer that question, but I still believe that this has the capacity to, or the potential to inform those people who will be better able to deal with those types of questions. Thank you. There are many more questions.
questions, so I think maybe at the break and also at the end of before we go to the trip today, we will have time for confidence. Okay.
Do you want to use the mic or?
No, I think I can. I get excited and nervous, so I talk loudly. I think you will hear me. So most of you probably think that diversity and heterogeneity, people use it synonymously. And I will try to convince you to think otherwise about these two concepts. Think about my watch or a cell in my body. You would not say that the parts of my cell are diverse. Think about the paintings here on the wall. You would not say that they are heterogeneous. And the parts in my cell are heterogeneous in the sense that their interaction and their differences, the interaction between different parts of my cell, are crucial to the functioning of the cell as a collective whole. Whereas for the wall, it functions excellent regardless of, it doesn't matter which paintings are here. Okay, so I will try to look at these different measures of difference because measuring difference is crucial in ecology. I will very briefly. Major evolutionary transitions. So what I would like to say here is that although these concepts are used synonymously, I will argue for a gap, and in some important contexts, even a tension, a trade-off, a conflict between diversity and heterogeneity. And I'll try to argue that that difference can be of relevance, maybe to ecologists, maybe to you, and maybe to social science. But I will only have time for one example, so I'm choosing the evolutionary concept. So I'll give a very brief and shallow and superficial review of certain ecological measures, variance, covariance, diversity. I don't even have, okay, we'll see. I'll look at them and then suggest an additional measure of heterogeneity. I will argue that these measures of difference, variance and diversity, we won't we'll have very little time to go over that, but I'll say that as they are, it's not enough. So we need another measure of difference, which looks at interactions, okay, and counts them. And by the help of Aaron Allison, who is doing the mathematical heavy lifting, and I will show you, I'll present a measure of heterogeneity and pick a context. And the context will be models of evolutionary transition. And then I will argue that in this particular context of evolutionary transitions, group diversity and heterogeneity differ. And they differ in important ways. That is, diversity and heterogeneity measure different causal factors. Okay, when you want to model a major evolutionary transition to individuality. Okay, and therefore, conflating heterogeneity and diversity, or just sufficing with diversity, okay, could sidetrack models that attempt to explain major evolutionary transitions to individuality. And this is just a suggestion because it's the very preliminary beginning of this line. So it's up to you to think whether this is relevant to you at all. And I'll accept a no answer. But I want to suggest this, okay? So I'm assuming, actually I'm assuming that you know what variance is. And I don't think I will have time to go over this, but we can come back to it in the Q&A. And yeah, I won't have time even to go over diversity. So I'm assuming that not only you know this, but you can read it very quickly. And what is important for me to state, that this is like, textbook 101 and nothing sophisticated here. And what I'm assuming is that when you have done counts, when you went and counted organisms in the field and wanted to measure biodiversity, you all notice that these measurements of diversity and of variance and of covariance, what they all do is that they ignore any kind of interaction. Even beta biodiversity, right, that people use for measuring turnover or population doesn't measure interaction. You don't measure how come one species got extinct. Okay, so you only measure presence. And however, interactions is often what matters causally if that species survives or not, right? And so what we want to offer is that all these measures who only count presence in proportion to relative abundance, they don't imply what you were talking so much before, so nicely. They don't imply and they don't measure any kind of interaction and any kind of differentiation between interacting with some other, and that other could be genetically or behaviorally or developmentally other, and interacting with same. But yet it is these interactions, their relative strength and structure, that is causally relevant, at least partly, okay, to targets that we want to model. And I want to say a little bit, yeah.
It seems like you're suggesting or assuming that heterogeneity and diversity are important concepts in understanding major evolution transitions, but I suspect that I don't understand
No.
Conception of what of how to define a major.
Okay, no, it's not an aim. It's a critical, good question, and I'm assuming that heterogeneity and diversity are very basic. I'm assuming that difference is a basic concept of how we understand and explain and count things in the world, and that we have measures of difference, and that we typically in different I don't have time for this, but in another paper, I describe how social scientists use diversity, how statisticians, how ecologists, and heterogeneity. And in this talk, I want to try and offer maybe these concepts could be relevant also for discussing evolutionary transitions. Maybe not. Okay, so I'm trying to use this in a new concept. That's why no is also a good answer. Okay, but let's look at it a minute. Okay, so let me okay, so maybe we should try to look at interactions, and for that what we use is standard analysis models of ecological network metrics. Okay, and what we try to build, it's not, I'm saying we, but it's not we. I'm the fly, I'm the Aaron, okay? So to suggest an index of heterogeneity, and we want to say something about degrees of heterogeneity, from the simpler to the more complex, okay? And maybe that can determine to what degree that collective entity with different parts of it, or that entity with different parts of it, is actually a collective whole, and in a sense, an emerging new individual. So, just very briefly, what is a network? That's not a definition, nor is this, but a network is consistent of a set of interacting nodes, okay? Here are 3 examples, and these nodes are connected by edges, and these edges define the relationship between the different nodes, and you can also count them, the edges, and you can look at their organization. So they may be weighed, you can weigh them, okay, both by their abundance and by their strength and their direction, okay? It gives you a good toolbox, okay, to look at interaction. Another option, of course, you cannot weigh them, just like counting. Okay, so in this measure of heterogeneity, what we suggest is two basic quantities: the number of different nodes, okay? These nodes can be, say, whatever example. So we count the number of nodes, we count the number of edges, okay, between nodes. And if every node is connected to one other node, okay, this is the total, okay, number of edges. But in most networks, not every node is connected to every node. Now we can define the connectedness of this collective, okay, and this is the connectedness, see, of a network, and it's defined by the number of nodes that do connect relative to those who could. And you have this basic C measure of heterogeneity. So you can talk about heterogeneity with a certain kind of measurement, okay? What it tells you is that in a certain group, however diverse, okay, so the formal representation of heterogeneity is different than the formal or mathematical representation of diversity. So no matter how diverse, a group of entities will have C equals 0 if none interact, and if there's more interaction, so we'll see. And a fully connected network will have C equals 1. Why does this matter? So heterogeneity as measured by C quantitatively identifies a baseline for group collectivity. Above C equals 0, okay, and of course it's context dependent, the network is no longer a pure aggregate. So we talk about these gradual differences from an aggregate to a collective, okay? And you can say something, you can quantify perhaps this change from an aggregate to the beginning of something different than an aggregate by this measure. But that's not enough, right? Because we only have a number of connections. It really matters the structure and the strength of the connection. And for that, we have ascendancy. I can never pronounce it right. And that is another measure of heterogeneity, the ascendancy of the heterogeneous collective. And the most important is this measure of transfer. So the transfer of materials, energy, information, whatever, but you can measure the, well, this represents a measure of a transfer of materials from one node to the next. And what it gives you is a combination of the network's overall internal organization and the amount of content or the material, energy, and information that flows through it. Why is that relevant? What?
What does the dot represent? T dot dot, T dot dot.
You see, that is why that it's a problem that Aaron is not here. He sent it to me last night. So I was, no, this one. So actually, I'm just, you know. So he's been working on this for a few months. We talked about this idea, but I'm transferring something that, as I say, I'm saying we, but it's not. I don't know how to answer you, but I'll be happy to connect you, and you will be happy to connect with all of them. So, say that again.
It's the law of an interaction effect in an analysis event. You take Tij plus T dot dot minus the single components. And it's like an epistatic measurement or an interaction measurement in an analysis of data.
Thank you. Okay. So what we have now is perhaps, okay, a measure that quantifies the degree to which a network behaves like a collective whole, okay, which in our evolutionary context is the degree to which some kind of level of individuality is emerging. And I come to all this from a more conceptual aspect. And I want to say this. Look, the difference between diversity and heterogeneity is not only of mathematical representation. It's not even the most basic thing. The most basic thing is how we, without even saying how we think, how we perceive the world, okay? Our most basic intuitions that it's weird to say that the pictures are heterogeneous. And it's not weird to say, okay, that the parts of the cell are heterogeneous. And attributing, what it means is that when you attribute heterogeneity to an entity, it implies, you imply that there is some potential for a collective whole there, that the differences serve, that the interaction between the different parts serve a collective whole. And while you attribute diversity to a certain entity, you have no such pre-assumption, okay? So what it means is that diversity does not describe well collectives, while heterogeneity is limited to describing collectives. And more importantly, heterogeneous or heterogeneity implies a collective that holds to a lesser or larger degree complex and coordinated interactions. And diversity assumes or applies to collections of entities. Now, I used this before more in social aspect. When you think about things that you talked about, like joint knowledge. What does that mean, joint knowledge? Okay, it's not just an assembly. It's not just an aggregate of majority vote. Okay, and it's relevant to things in ecology and ecosystem. Okay, it's not just alpha. You don't just count from the number of species you have and you get an ecosystem, right? An ecosystem is not a collection. And if you model it and describe it only as a collection, it might be a problem. Okay, so because of this difference, what we say is that in a sense, diversity already pre-assumes divergence. So when you use diversity, it's not neutral. This is not like a technical neutral measure of difference. No, it has these pre-assumptions that we didn't notice, okay? And in some contexts, diversity and heterogeneity, they don't just look different, they contrast, okay? So, if we check that how people actually speak, does these intuitions, really it was just walking with my dog, and does these intuitions fit at any way how people actually speak? And so we searched these large databases of Coca and Wikipedia, and there's, I think, 560 million or 520 million words in each one of them, okay? And it gives you tools to find the co-occurrence of different words and draw and ask hypotheses about their co-occurrence. What we found is that when you, words like collective, whole, integration, interaction, they co-occur significantly more frequently with heterogeneous than with diverse. And it improves your prediction by 8 to 24, depending which word you choose. Okay? So it somewhat supports our assumed meaning of heterogeneity as interactions among different kinds of entities, within a collective whole, and the implicit lack of collectivity when you measure diversity. Just think, okay, if I get to it, if I have time, I'll get to it. And now, how can it be maybe relevant to evolutionary model? So first, a word about what is a model, and it's an incomplete representation specified by descriptions. A description can be an equation, a picture, words, okay? Different kinds of description. They typically have a ligand next to them, and including causal descriptions. And a model will typically have an interpretation. The interpretation is like your prediction. The model, the interpretation examines the fit between the model and the target, okay? And it also evaluates how fit the model is, okay? So, what is a causal description within a model? Here I'm going more slowly because I assume most of you are not philosophers. And a model's causal description amounts to identifying a factor that makes a difference for an idealized model. What does it mean makes a difference? It makes a difference in the sense that if you remove that causal descriptor, it prevents the model from entailing the occurrence of the phenomenon. So it changes the prediction, the interpretation. Okay? Now, if we have these models for major evolutionary transitions of individuality that represents a target, not well, what is the major evolutionary transitions? I'm not going into that at all here. There are way better qualified people than me and I. But I'll just use a common feature, which is, thank you, entities that were capable of independent replication before the transition can replicate only as part of a larger whole after. Now, if this is our target, we try to model it, and we try to model it with causal descriptions, okay? You can have a model without a causal description, right? Just think of climate models. So if you want to represent a target, okay, now, such models aim to represent a target, okay? Not what, well, where did I go? Okay. Now, when I will describe these models, I'll use a very common, Lloyd repeats this, a common feature that says major evolutionary transitions has 3 major phases, okay? And it follows Hassler and Dummett ML1 and ML2 in its different forms. And I really like Okasha's book and the way he takes these statistics and builds very simple causal graphs. Okay, so let's look at the first stage. Okay, so in this initial stage, an individual's fitness, okay, an individual fitness is caused by the individual's character or trait. Okay, and the correlation that you have between the group trait and the individual fitness, it's a byproduct. It's a statistical byproduct. The causal arrow is here, okay? So a strong correlation or a high covariance between collective character and individual fitness is a mere statistical byproduct. Think, for an example, Williams has this beautiful and very famous example of a herd. If you take a herd of gazelles running, okay? And I think it was raised here before by something of that kind by unknown. So if you have a collective character like the average speed in the herd, okay? And it would fit the fitness of there is a covariance between the fitness of an individual relative, its fitness relative to the group he belongs to, a group that runs fast. Of course, it doesn't mean that the group somehow, the group trait somehow affects the individual fitness. Okay, that goes against Emerson and Ellie and the Chicago School, finding group fitness and group selection wherever they looked, and finding altruism wherever they looked. So what you have here in this initial stage is the causal arrow is here, okay? And what would you expect in this situation is low heterogeneity, and the diversity could be high or low. They're not attached in any way. Now, in the second stage, what you have, once a collective, once there's more and more interactions between the individuals in the group, what you have is a proportion. It's no longer a direct correlation, but you would have a proportion, okay, that exists between the individual character and the collective fitness, okay? But the collective character that causes the individual fitness is just an average of individual fitnesses, okay? So this causal arrow here, the collective character here is not this emergent property that is unique or more than the average of, or even sometimes even the mean, okay, of the individuals within the group. What you would expect here in this stage is that both the heterogeneity and diversity would increase, but not necessarily in the same way. Still, you would find heterogeneity would increase because you would find more connectivity and beginning of acidity. But at the last stage of this scenario, you would have a direct proportion, no longer expected, between an individual character and fitness. And that is because the individual character, the individual fitness, is caused by a collective fitness. I didn't say before, I didn't give an example here. Think of here of trait group selection. Okay, D.S. Wilson's trait group selection, it fits nicely into this causal ties. Now think of interdemic selection. But more importantly, it's just one example. But think of this case where you have the particle's fitness caused by the collective fitness, and the collective fitness is decided by some collective trait, I don't know, division of labor, a trait that is not just an average, okay? And I'm thinking of your example, you would have, you can't just say that the average growth rate within the collective decides the collective trait and the collective fitness. Some would grow very fast and it won't help them. Some would grow very slow, and the organization within the collective would matter. Okay, so we're talking here about a different type. What happened? Okay. So in this case, in the last case, we're looking for a trade-off. We expect a trade-off between heterogeneity and diversity. If we have a non-egalitarian inheritance system, so a new level of individuality will hold very high heterogeneity and a low diversity. So high heterogeneity will maintain this new level of individuality, for example, by division of labor, whereas high diversity now could hamper, like genetic diversity, could hamper this new individual emerging, okay? And why? Because it will increase the inner divergence, and it will increase the chances of individual dissolvement. And And here we have a trade-off between diversity and heterogeneity. And the conclusion, I have time just for the conclusion, is that okay, diversity is not heterogeneity. Nor will increasing the former somehow increase the latter, okay? And since, why is that not so? Because in some non-trivial context, these measures describe conflicting causal forces. I'm wondering if you think that's relevant to you. I'm sure it's relevant to issues in social sciences when we speak about diversifying the campus, and all university and colleges, they just want more diversity, and sometimes it's not, I don't have time at all to, this is a different paper, but often this increased diversity comes with increased alienation, feelings of isolation, and then the grades of minority groups drop down, okay? And it creates this positive, not positive, but a positive feedback with horrible consequences, that the person who is doing less well is being accused, because the victim is to blame, okay? Because we diversified the campus. We brought you in by, how is it called in English? Affirmative action. We brought you in by affirmative action, and still you don't succeed well enough. There must be something wrong with you. I'm not talking against affirmative action. I'm talking against the conflation of diversity and heterogeneity and sufficing just with diversity. Okay? That's it. Thanks.
Basically, we are talking about interactiveness and I don't understand. And you
interactiveness between different things. That's why heterogeneity is important. Okay.
Well,
yeah.
Interactiveness can be between different things, and it can be between the same things. And for example, it depends how you define it. Interactiveness between things that are similar is also very, very important. For example, cells within the body, within tissue. So that is also very important. So I'm wondering, I think that heterogeneity is a little bit confusing for most people. This difference, I think that if you use interactiveness, it will be much clearer, at least for me. So that's just a comment that I wanted to make. The other thing that I wanted to make is, yesterday we had a lecture about wasps and about the fact that there is a huge diversity in differences between the faces of the wasp. Now, and a very important question is to what extent there is a difference. So too great a difference may be counterproductive. Identity is also counterproductive. So you have to find kind of middle way. How is this? I didn't see it represented in your model.
Okay.
Now, and the third comment, and I think it should, because I think this is important, because without this kind of heterogeneity, this kind of diversity, this kind of differences, you will not be able to. There will be a limit to the amount of interesting interaction that you will have. A third thing is, as you noted, the organization is very important. So when you are looking, for example, at the eukaryotic cell or even the prokaryotic cell, what you see is not just that there is more interactive, but or heterogeneity, but that it is structured. So you have different organelles. So there is structure within the structure of interaction, and this is crucial. And again, I think that if you want to have a model for major transitions or for major changes in organization during evolution, you have to take this into consideration.
Okay. So let me see if I got it on. First, the last point, what I talked about with Aaron and what he tried to build in that equation is exactly being able, not exactly, but somewhat being able to answer not only the number, the amount of interactions, but how are they structured? That's the whole idea behind this ecological network metrics that he took. There's a whole bunch of literature from there. He took it, worked on it, trying to use it in a different context. What it gives you is the ability to measure which nodes are more connected with which nodes, in how frequent is the flow between them. It gives you structure.
But it doesn't tell you how the hubs are interacted with, are organized within the system. This is what it gives. This I understood.
Okay.
Okay, so it's another level.
Okay. So first of all, I'll need to write that down and go back to him. Another important thing is that what I'm asking you to do is not to think of difference as one thing. You see, it's two different types. So I'm not sure if I'll look at the WASP example. Okay. So there are differences there in the facial structure. But if these differences matter for interactions that are relevant for this collective thing, I'm not sure the correct way to measure it would be, I don't know. I don't know at all. But I'm wondering whether measuring differences through by looking at them as heterogeneous differences rather than diverse differences could make a difference when you model the phenomena. I'm asking. And it could be. It could be. Why? Because when you think of diversity, the group, whether I'm talking about just a second wasp that I'm fighting with, or 5 different more that I'm going to build my nest, the group doesn't matter in diversity, right? It doesn't matter. In heterogeneity, it makes all the matter of the world. So I'm not sure, but I'm offering, okay? I'm begging you to use it. I guess what I tried to, it doesn't help at all. I guess what I tried, I guess what I tried to show, I wanted you to see a case where diversity and heterogeneity conflict. You would not think they conflict. And I think at the last part of a transition towards a new individual, yes, you can see the conflict between 2 measures of difference. And wait, this one and no.
Yeah. So I don't know whether you know it. 2 years ago.
Probably not.
Together with Niels Penseth, Simon Levin, Jan Nordbotten, we produced a paper with the title Ecological and Evolutionary Dynamics of Interconnectedness and Modularity. Yeah. Now, the point of that paper was exactly that if you want to know what's going on in more biological terms, what you have to do is that you have to combine diversity measures with different measures of modularity, and then we come up with an integrated concept of this interconnectedness that actually is consistent what you showed in one of the slides. There are 2 points here, though, that of course this kind of interconnected evolution is happening, all the way, right? So it's happening under normal ecosystem development without any major transition. So it has its own dynamics. So what I'm saying is what leads to the major transition is a subset, is a very specific subset of the interconnectedness dynamics. And somehow we must have, a go at it. Now, in our formulation from 2 years ago, there is also the dynamics, so that we can actually follow the population dynamics across the whole trade space. The problem is that what we don't have is some kind of a formulation of exactly the co-replication effect. What you started with the major transition, because technically speaking, we don't know how to handle it, because in a way, I'm using it somewhat metaphorically, if a major transition was to occur in that particular mathematical framework, it would be something like a singularity, where the original formation actually breaks down. You see, it's not a trivial issue. It's very important, this heterogeneity effect, but how it is coupled with the core application aspect is technically very difficult. And
so I think it also comes back to what you said. And we're thinking whether that kind of measure can help you say something about the direction of when something is becoming more and more and more with a collective nature to it. But at this point, this crucial point, I don't think I can offer something, but I don't know. I don't know.
It's not clear to me that geneticists, since the foundation of the subject, actually bothered about whether diversity is different from heterogeneity and describing how much variation there is between and within genetic population, genetically defined population. Nevertheless, diversity has a very precise meaning, and so does heterogeneity, even though they're very often used synonymously, because if you have a bunch of populations, in each population you measure how much genetic diversity there is by the heterozygosity, a very simple measure. You look at the set of genes, you look at the heterozygosity, the more heterozygosity there is, the more diverse the genetics of that population. A very simple concept. But how do you compare populations? Then that Fisher and Wright introduced, using different terminologies, exactly the same concept using analysis of variance. So you could say that there's a statistic called FST, which measures how much relative diversity there is in the whole system. And that is a very simple function of how much migration is going on between the different populations, which is how much connectivity there is between the different populations. The higher the FST, the less connection there is. And the higher the FST, the more different the variation between the different populations is. A very simple notion, widely used since the 1930s. It doesn't require that you go into network construction of this kind of thing. And actually it forms the basis for the statistic that you wrote up there with the TIJs and all that sort of thing. In ecology, you ask.
Wait, let me just come back to that for a minute. I think that's a really helpful point. When you go to Fisher's original, well, not also the 1918, but the 1925 paper, when heterogeneity is used, it's the heterogeneity is a problem you need to solve in order to compare, right? So you first need, if you reach a heterogeneous heteroclassic, I don't remember how exactly he says it, but when you have heterogeneity, it's a problem you need to overcome for reaching exactly what you want. So the way he uses heterogeneity is not the way we want to use it here. It's something that needs to be mathematically overcome in order to give what you said. And I think what we're doing here with heterogeneity is different because it's targeting a different aspect.
If you were to take a community which has 20 species, each of them at 5, but 20, each of them representing 5. So you've got 20 samples of sparrows, and you have 5 of this one, 5 of that one, 5 of that one, 5 of that one. And then you compare that with 20, another world in which there's 17 of this one, 1 of that one, 1 of that one, 1 of that one. Ecologists for 50, 70 years have been describing the former as more diverse than the other one, simply using Kitchen's energy measure, the sum of P log 1 of T. That's a standard kind of measure related to what this AIJ is. I'm wondering, what's the problem? Why do you need something?
Okay, so that I can answer also from field work, because Fisher's, I only read his papers, but I don't really use them. I'm not good enough in that. But in ecology, so I go out with ecologists, and so I did the same thing. I went with Harvard Forest and a group at Berkeley and a group at Israel. all of them had tried to measure biodiversity, okay? And all of them thought that the standard tools that they have for diversity, even when they don't use only alpha diversity, the standard tools that they have do not touch upon the problem that they want to solve, okay? Because it doesn't touch upon interactions, and I really want to read that paper. I don't think what they have today, they're not happy, okay, who am I to judge? They're not happy with what they have. That is all I can say, from working with them in the field, okay? So this might be level. Don't we have like a coffee break? I don't want to. Oh, sorry. No, I'm not running the time. It was it was the fun. When I'm talking, someone else has to run the time.
Okay, so it's time for a coffee break.
No,
Yes, it's a treat.
I really want to talk with anyone who has a question and find all the flaws that you can see. Okay, thank you.